Let's say that you arrive at the university. But instead of taking classes, you are asked to organize the data that we use to run this organization. What data would you collect? And how would you store this data? How do we even start thinking about this? Okay, let's think. We have students to keep track. We have classes. We have professors. We have staff. We need to keep track of payments, incoming and outgoing. But we also have buildings, labs, student clubs, and many other things. How do we organize all this information so that we can make sense of it? In this lesson, we'll talk about the entity relationship model, a highly influential model of thinking about data, which then provides the logic of how data is stored and organized in a database. The entity relationship model revolves around two key concepts. You guessed it, entities and relationships between them. We'll see that entities are described by attributes and keys, and relationships are defined by their cardinality constraints. And we'll explain what this means in detail. In this video, we'll talk about entities, so let's start by examining first what an entity is. When we're talking about entities, typically we are talking about some abstract objects. For example, in a university management system, we have students, we have courses, we have instructors, we have classrooms. All these are examples of entities. In the entity relationship model, each entity is described by a set of attributes. So for example, the student entity might have first name, last name, year of birth, and gender. These are the attributes that we have for the student entity. Then a course may have a course name, course description, credits, and potentially other details. Now, one very important part of the model, each of these attributes has a domain of possible values. At the very simplest level, the domain is very simple, so we can specify, for example, that first name and last name consist of text, and that's the domain. If we take a look at the year of birth, the domain for this attribute is a number, and we can potentially limit this number to be an integer between 1900 and 2020. So for the attribute gender, the domain may be two values, male and female, not M and F, not men and woman. Potentially, we may want to allow additional values in the domain for the attribute. For example, we can allow not specified or potentially other values if we want to, but we would not allow both M and male and man to coexist in the domain of allowed values. As we're going to see later on, defining the domain for an attribute is one of the most important things in a database system, which helps a lot with data quality and consistency. Once we have an entity and its attributes, the entity describes the structure of all the instances of the data that we have in the database. So for example, let's say that we have the entity student. For each student instance, we'll then record the first name, last name, year of birth, and gender for the student. So we might have, for example, an instance of a student called Peter in the first name, Pan in the last name, 2001 year of birth, and gender male. And of course, we can have many more instances of students in the database. And the key thing to remember is that for each student instance, we'll record exactly the same attributes: first name, last name, year of birth, and gender. Now, if we take a look at the entity courses, we know that each instance of a course has a course name, course description, and credits. So each course instance will have a name such as data analysis, a course description such as learning to analyze data, and a number of credits, let's say 4. Primary keys. When we are discussing attributes, we need to mention one very important concept in databases, the concept of a primary key. What's a primary key? Primary key is an attribute whose value is unique for each instance of an entity. So for example, for the student entity, the student has a unique student ID. A primary key has the following characteristics. Each instance has one and only one primary key. So you cannot have multiple primary keys for the same entity instance. Also, two different instances of an entity cannot share the same primary key. So, for example, in the case of students, if a student has student ID as the primary key, a student can only have one student ID, and the student ID cannot be assigned to more than one student. Most of the time, a primary key tends to be a single attribute, but sometimes we can have what we call a composite primary key, which means that the primary key consists of two or more attributes, and if we put them together, they are unique for each instance of an entity. So, for example, a course might have a course ID and a section ID. While we might have courses that have the same course ID, we don't have a course that has the same course ID and the same section ID together. What are some other examples of primary keys? If you think about it, there are many examples of relational databases in everyday life, and we have quite a few examples of primary keys for that reason. So, let's think of a few. So, for example, we have the social security numbers for US workers that contribute to the social security program. That's the primary key for the US workers. We have UPC, Universal Product Code, that identifies uniquely a product in a store. That's another primary key. We also have serial numbers that uniquely identify a device. Even though they might be the same product, each device has its own serial number that uniquely identifies this device. We have the VIN, the vehicle identification number, that serves as a primary key for identifying a vehicle, and so on. Notice a few of these keys may not be great candidates to serve as primary keys in different contexts than the one that they're being used. For example, if you use the social security number as the primary key for students in a university, then you face the following problem. International students typically do not have social security numbers. So, if you want to store data about the students in a database, you need to invent fake social security numbers for entering the students in the database. If later on they get an actual correct social security number, then we have the issue that the same entity may appear with different primary keys in different places in the database. Some will have the old one, some will have the new one, and this is expected to cause all sorts of problems. Therefore, it is always better to create keys that are designed for a particular application instead of trying to reuse keys that were used for other purposes. So, in this video, we examine the concept of entities and how we can use attributes and primary keys to represent these entities. In our next video, we'll talk about the other important part of the entity relationship model, the concept of relationships between entities.